Huda, thanks for agreeing to talk with me.
Yeah, I'm so glad to be here.
So would you like to introduce yourself and tell folks where you are and what you're doing right now?
Sure. Yeah. So my name is Huda Nassar, and currently I'm a postdoc fellow at Stanford University. My lab works primarily on biomedical data, and we try and do all of our research is related to predictions and data science, the stuff on biological data.
That's fun. So I noticed that a lot of your postdoc work has been on graph theory, and the Groxio community has been introduced to graph theory from the perspective of Prolog, right? So we built some
Yeah.
solvers and things like that. But the naive version of what you're working on, right?
But actually, another thing I didn't mention in my introduction, you caught me at an interesting intersection point in my career, which is I'm moving from my postdoc in the next 15 days to a new job, where the new job I'll be using Julia primarily, and I'll be working on graphs specifically, knowledge graphs in specific. So yeah, my if I want to pick two main things that I really like to work with are graphs and Julia, and now the new job will intersect these two things.
So I want to talk about how this came about. I mean, you're pretty young to be involved in a new emerging language like this. So how
Yeah.
did you start working with Julia?
How did I start working with Julia? So actually, my very first year of my PhD, I had just started. I think I had just taken my very first project, like tiny little project from my advisor, kind of like get um, get to know what my research area is going to be and how it's going to look like. And I think 1 or 2 months in, we had a problem where we had to generate like really large graphs. We're talking Boolean node graphs. And we really wanted to generate this data to kind of study some property on a specific type of graphs. And the long story short is that our previous pipeline would have taken days to get the thing done. And the next pipeline was like, okay, what do we want to do? Like, we have the code to generate all of the stuff in C++, but the problem was in our previous paradigm, like we would write up everything in C++, like generate the code, but then it writes to disk, and then we want to read from disk. And then reading and writing from disk was just like really taking a long time. So what we did as a very first step was we went and wrote a wrapper in Julia to wrap the C++ code. So now you have the C++ code, but it's as if like actually a Julia function. So like you're calling it from Julia, and then you're manipulating all the graph stuff from Julia, which is very easy and user-friendly. And then the whole process, everything we wanted to generate was like taking about 3 to 4 hours at the latest, at the most. So it was a really big difference in terms of speed and time performance. So we immediately just thought, okay, that project has to be in Julia. And we just started writing everything in Julia. I personally, another factor is like you come, usually in Julia, like the hook is the speed, like you get hooked to it in your very first attempt because it's so fast. But then beyond the hook, you're like, oh my God, this language is really cool. And like you start finding all these amazing features, and you're like, oh my God, more features. And it becomes addictive at some point.
Right. So, I mean, there's so much to unpack there, right? These are all the reasons that people come to Julia and actually wind up staying there and loving it, right? So,
Right.
first you talked about the speed, which is kind of a given, right? Because what has happened is so many people have gone from traditional data science packages because they don't have the general language capabilities. I mean, the problem is that you can't escape, right? So then you go to Python so that you can escape and get out, and then it's too slow. And you find yourself working in this, like you said, with a C++ and the Python, and then your iteration time is so slow, or you can't get the speed out of the platform. Wow, that's so cool.
Yeah.
So it seems like you're almost the ideal data scientist that they were targeting when they built this thing.
I don't know. Yeah, I think a lot of I've seen, and I'm still seeing people from the data science / machine learning world coming to Julia and trying something out, and they're like, whoa, this is really cool. And I think, yeah, obviously I was one of the targets that Julia was a really good hook for me, but I think it's honestly, I don't like to just frame it as a language that only data scientists enjoy or machine learning people, because it's really much bigger than that. There's the aspect of like wanting, like if you want to go, if I take off my data science hat and put more of a computer sciencey techie, like I want to get into the details of what's going on in the code hat. I'm thinking, well, if I want to make something faster, I go and look at the Julia code and I realize Julia gives me all of these superpowers on the code. Like I can actually manipulate so many things and get the best performance and speed out of it. So it satisfies the data sciencey aspect of me, and it does satisfy the computer sciencey aspect of me to get both from the same language. So I think I love that about it.
Yeah, that's so cool. It's almost like you have a stool, right? And there are three legs, and one of them is kind of this high performance leg, and that kind of feeds the beast that the Python users are coming over from, right? And then there's the abstraction side that Python is beautiful in some ways, R is beautiful some ways, but they don't have the programming abstractions, right? Like macros are a big deal, something you can write a language in, something that you can. And when the abstractions are right, everything moves so much faster.
Very true. Yeah.
Yeah, so let's talk about your involvement in the Julia Academy. One of the things that I noticed for being away from this community for a while is that there's this explosion of excellent learning content, and you teach some basic data science. And one of the things that I noticed is that you spent a good long chunk of time talking about the general programming capabilities in Julia of actually loading this data in, right? And trimming it down and dealing with your missings and doing the data frames or arrays and all those pieces. Talk to me about how you decided to spend that much time on these aspects of Julia.
Yeah, to be very honest, I think this this course didn't, I imagined it would be like a 1 hour thing initially. But then I started working on it and like adding, and it just like became so much bigger than I thought it would be. I did want to add a data part to the data science. So like, I think the course is structured, like you work on the data first, and then there's all like a bunch of data science methods. And then at the very end, there's the visualization section. I did want to work on the data for one simple reason, and that is a lot of times we basically just gloss over this aspect. Like we just don't think about it. And honestly, one of the biggest things as someone who works with data a lot, I do value actually spending quality time with my data. Like before I even start a method, before I even like run a model, regression model, whatever it is, I just want to spend some quality time with my data, just play around with it, maybe plot a few things, see how, is there anything fishy going on? And the reason we did this very first section is, well, here, these are the ways you can play around with inputting and outputting your data in and out from wherever you have your data saved. And here are all the data structures that you could use to help you use your data in a meaningful way. Like if you want to use a dictionary, it might be useful for this kind of experiment. Or if you want to use a data frame, it might be useful for this kind of experiment. And I personally value spending quality time with data. And that's why I really wanted to have this notebook there in the very, very beginning to talk about all kinds of packages for input output, all kinds of data structures, how you play around with your data before you get into actually doing any data sciencey tasks.
Yeah, that's really cool. So data is either new or it's pure, right? It's very rare that you get like a pristine chunk of data.
Oh, never. Yeah. If you get like pristine data, there's something fishy. There's something going on.
Somebody's cheating, right?
Yeah.